Hello friends, it's Gurpreet here. Today I am going to discuss about the Michelson-Morley experiment. In 18th century, light was supposed to be a longitudinal wave, and we know that longitudinal wave require a material medium to travel through, like sound waves. They require air, and water waves. They require a water medium. So, like that, there should be a medium through which the light travels. The scientists have proposed the hypothesis that there exists a ether medium all over the space through which the lights travel through. In 1887, Michelson and Morley conducted an experiment to test for the presence of this ether medium and to check its properties. They conducted the experiment by building an apparatus called as interferometer. Here we have this apparatus. In apparatus they have one source of monochromatic light. Here we have a semi-transparent mirror. And two mirrors M1 and M2 are placed perpendicular to each other, such that part of the light transmitted by this semi-transparent mirror falls on the mirror M2 and part reflected by this semi-transparent mirror falls on mirror M1. These both mirrors are perpendicular to each other, and this semi-transparent mirror is equally inclined to these two mirrors. The distance of this mirror M1 and M2 from point O is kept equal to L. Let this transmitter ray be R2 and this reflected ray be R1. Now the whole setup is at rest. So now when the rays bounce back from mirrors M1 and mirror M2, it will rejoin here and form an interference pattern at the detector telescope. So now we will see the fringe pattern here because they both will be in the same phase. Now as we know, the earth is rotating around the sun with certain velocity, and our setup will also be moving. So there will be a actually relative velocity between the ether medium, that is space, and the earth. So let be the relative velocity be v between the ether and the earth. Now let the speed of light be c, and it is parallel to velocity v because our source should be kept such that its beam is parallel to velocity v. Now the m1 will shift to point m1 dash, because as ray emit from here, when till the time it reach the m1 will be shifted to the right. So we will take it point as a m dash. And it will reflect back to the point O dash. So by time O will also be shifted to O dash, and M2 will be shifted to M2 dash. So now both these rays R1 and R2 will not travel equal distance. One of them will we have to travel the greater distance. In this case, R2 will travel greater distance than R1. So when they bounce back from M2 and M1, there will be a certain path difference between these two rays, and we will now observe this pattern here. The telescope will be now here. So if the path difference will be in phase, then constructive interference will take and we will see fringes here. But as we know, it's not necessary that they will be in phase. So when they are out of phase, there will be a no interference pattern, and we will see two diffused points like this, one from the M1 and one from M2. And we will check this by rotating this apparatus, because at certain angle like this, we will rotate our apparatus at certain angles. These two paths will be equal, and for certain time these two will be different. So we will have we expect that at some time we will see this like diffuse 2 points, and sometime we will see fringe patterns. But when we actually rotate this whole apparatus, only fringe pattern will be there, and there will be no shift in the fringe pattern. But if we see theoretically, there should be a fringe shift. Now we will do the theoretical part. Let be a perpendicular from M dash on O dash be fall at point D, and it's a right angle triangle O M dash D. Here we will apply a Pythagoras theorem on this triangle. Let T be the time taken by ray R1 to travel from O to M1, and we know that OA dash square is equal to OD square plus AD square, and this is ray travel with the speed of light, so this distance came out to be a CT, so it's CT square, and this shift will be VT because our apparatus is moving with the velocity V. It came out to be VT square, and distance we know that it's a L, so it's L square. From here T will came out to be L upon root of C square minus V square. But we know that OM dash will be equal to M dash O, and the time taken will also be equal. So actually from traveling to O dash, the ray will take 2T. We will multiply it by 2 and we will read it as a T1. T1 is equal to 2L upon C root of 1 minus C square V square upon C square. And we will rewrite this like this. As we know, V is much smaller as compared to C, so we can take binomial approximation here. Now T1 came out to be 2L by C into 1 plus V square upon 2 C square. Now we will calculate the time for the ray R2. Let T2 be the time taken by the ray R2 from moving to O to M2 and returning back from M2 to O dash. This time will be we know that time will be distance by velocity. So when the ray will travel in the direction of the movement of our earth, both the velocities will get added, so it will be L upon C plus V, and when it will return back, the direction will be opposite. It will came out to be L upon C minus V. So we will take a binomial approximation I had taken above. We will came out to be T2 is equal to 2L by C into 1 plus V square upon C square. We have named this expression I2. So the actual path difference between both these two rays will be the velocity. Velocity will be constant, and the time difference. Time difference we will calculate from the T2 minus T1, the above we have calculated. That will came out to be L V square upon C cube. And when we multiply it with the velocity, it will give us the path difference between these two rays. So the path difference first will came out to be L V square upon C square. Now we will rotate our whole apparatus by a 90 degree. So when we rotate apparatus by 90 degree and perform above all calculations, that path difference will find out to be a minus L V square upon C square. So the actual path difference between these two cases, angle 0 degree and 90 degree, will be del x1 minus del x2. It will came out to be 2L V square upon C square. And number of fringe shift will be del x upon lambda. Here lambda is the wavelength of the monochromatic light used. So it will be 2L V square upon C square by lambda. And we know all these constants. C is speed of light, lambda is wavelength of monochromatic light, L here is the length of the mirror from the semi-transmitting mirror, and V is the speed of earth with which it's rotating around the sun. So we can easily find this n, and the n will came out to be 0.4. But actually as told before, there will be no such fringe shift. At any angle, the pattern we found here is same, that is a circular fringe pattern. So we can conclude from this experiment there is no such ether medium exist. So the hypothesis was wrong, and there is no such ether medium. So we can conclude that the light travel with velocity c in all the directions, and the hypothesis y wrong. I think this video will help you, so thank you.